This is Physical Chemistry, Part 1, Thermodynamics, Chapter 4, Thermochemistry, Section 4.1, Energy stored in chemical bonds is released or taken up in chemical reactions. So first, I want to talk about these two equations. They are very confusing because in the first equation, you see Q is equal to delta U. In the second equation, Q is equal to delta H. And we know H and U are different. H is equal to U plus PV. How can these two equations be all correct? Well, look at the condition. At constant temperature and volume, Q of the reaction is the internal energy change. At constant temperature and pressure condition, Q is equal to the enthalpy change. Now let's get back to this equation. du equals delta U over delta T times dt plus delta U over delta V times dV equation for physical changes. When there's no chemical change, this equation is correct. And when the temperature and volume are both constant, du is 0. However, when there is a chemical change, some chemical bonds are broken, some new chemical bonds are formed. In that case, delta U is equal to Q when temperature and volume are constant. Similarly, dH equals delta H over delta T times dt plus delta H over delta P times dP, only if there is no chemical change. And if you look at this equation, when temperature and pressure remain constant, dH is 0. Because dt is 0, dP is 0, then dH is 0. When there is some chemical change, chemical bonds are broken, some other new chemical bonds are formed. Therefore, under this condition, even if T and P are constant, enthalpy changes. And what's the enthalpy change? It can be measured by it can be determined by measuring the heat of the reaction. Again, this is due to the change of the number of moles of chemicals involved in the reaction. For example, if hydrogen reacts with oxygen and produce water, the number of moles of hydrogen and oxygen will decrease. The number of moles of water will increase.